Hi, in this lesson, we'll be looking at what to expect with regards to paper 2, analytic geometry, with regards to circles. So we have your original, you have your circle equation here. This is for the circle that is passing and then the original, right? If I'm being honest with you, chances of I'm asking you about these are 0 to 9 because they're very much simple. What they will be interested in is center at any point, right? With regards to center at any point, this is the equation that we're going to have. Please note that these ones come with a negative in front of them. Please keep the negative there, and it will accommodate either the positive or negative you're going to find with regards to your center. Now, what they love to ask with regards to that equation is for you to take the equation from the not given standard form and turn it into the given standard form by using what we call completing the square. So yes, you're going to have to use this method. They love this one over here. This is something you should practice. So here you can see now, example, the first thing they did is put the x's together and the y's together and took our constant to the other side. So then they added half of what we would call b in our quadratic equation. So half of the coefficient of just x and squared it, and they added on both sides. So now your left hand side, there it is, and your right hand side, there it is. And this part here by itself here would give you a perfect square, and so would these, and your perfect square would then end up into minus 3 squared plus 1 squared, and you can add these together and get 16. This means that your center is a 3 and minus 1 and has a radius of 4. So yes, do practice this one over here. Another question that they love asking is for you to get the tangent, the equation of the tangent the equation of a tangent of a line that is passing by your circle there, right? So one thing that we need to always know is that the tangent is going to be perpendicular to the radius, meaning that if you can in any way calculate the gradient of the radius, then you will be able to get the gradient of the tangent. And the point that you're going to use is this point there, that the tangent shares with your radius to get the whole equation, and it's going to be a straight line. Now, other than tangents, we have other lines that are passing through your graph. We have, in this case, actually, let's start, before we get to that, let's start with these ones here, with other lines that are passing through your graph that are not tangents, right? We have your second, and we also have your exterior lines that are not touching. So you should be able to tell whether a line is second, tangent, or an exterior line. What you're going to do is that you're going to solve simultaneously your circle equation with your line equation. And if you get 2 points, it means that the line is a second, because a second will interact with your circle at 2 points. If you get just 1 point, if you solve for it and you get 1 point, it means that it's a tangent, because a tangent will only touch your graph at 1 point. And if you try to solve it and you get no solutions, it means it's an exterior lines and they are not touching. Now, another thing that can touch your circle is another circle. Right? So normally we'd have a big circle and a small circle. So in this case, we will let r be the radius of the large circle, and we will let small r be the radius of your smaller circle. Now, you're going to calculate the distance between the centers by using the distance relationship that we get in our analytic equations. Please check out the analytic equations to see the distance. You're going to use the distance formula to calculate, because remember the center has a point, right? Your A and B. You're going to use the center of the big circle and the center of the small circle to calculate the distance. Now, if the distance is more smaller, then these two are subtracted from each other. Then we say it does not intersect and it's inside of your circle. The small circle is inside of the small circle. If it is equal to the difference between the two radius, the distance that is. If it's equal, then they do touch, but they touch internally. So the small circle is inside the big circle again. Now, if they do, if your distance is then going to be equals to the, or in between the sum of these and the difference of the two radiuses, then you know they will meet at 2 points. If the distance is equals to the two radiuses added together, then you know that they touch externally. And if the distance is greater than the two radiuses added together, then you know that they do not intersect, they are outside of each other. So my advice here would be, the first thing you do when you get a question that will ask you whether the circles are touching or not is to first calculate the distance between the center. Right? Let's write that down. One is to calculate distance between the centers. And three is then to calculate the sum, the difference. Once you've done that, then you can compare the distance to either you compare it to this, or that you see if it fits in any of these three conditions, so that you can say whether there is interaction or not. Is it externally? Is it internally? Is it more than one interaction? To see examples on how this is done, please head on to the YouTube channel, or here on our channels we should have videos for you to watch with regards to past papers and see how it was done.